Hello guys, today I have with me two amplifiers, and how I acquired them is actually quite a funny story. Well, not this one, but this one. So anyway, the story goes that I bought this amplifier from a website which I found in France because the amplifier was quite cheap there. It was 95 euros. So I bought it from there, and it said that it would take 5 days for postage. So I thought, okay, perfect. So 2 weeks later, it arrived, and it came with this cable. Well, not this particular cable in particular, but a cable like this one. And so I wanted to test it out. I have my new Elec SDR plugged into my laptop. I checked it out, and the results looked pretty good, looked quite promising. So I plugged it into my miner, and yeah, I didn't see anything in the logs to say that this amplifier was actually working at all. So I was quite a bit, upset at the fact that I think it might not be working anymore. So I plugged it back into the SDR to see what was going on, and it showed me nothing. I was really irritated. I mean, when I turned it on, I could see something. But the results were very low. So I was really quite annoyed, to the point where actually I sent an email to the website that I bought them from and said, basically I've bought this, I've had it for 5 minutes and now it's not working, and I would like a replacement, but I don't want to wait 2 weeks because I don't have 2 weeks, because I'm in my apartment in Reutlingen and I'm not staying here for very long, and I need to go back to Switzerland. So obviously I need to do what I need to do with this amp today because the miner is here. So because of my limited time here in Reutlingen, I decided to have a quick look online on eBay and see if I could find another amplifier. And I found one not too far away, Karlsruhe. It's about an hour and a half, an hour. Rocketed up to Karlsruhe, got the amplifier, came back. So I unpackaged the Acasom just to give it a quick test. But I needed a cable to connect the Acasom to the SDR. So the cable was still attached to my AB868 amplifier, and as I took it off, I had realized I had connected the female end of this wire to the female end of the AB868, because they're both female on this. So when I realized my mistake, of course, naturally I was kind of annoyed that I'd just gone all the way to Karlsruhe to pick up an amplifier, which actually I didn't need. But hey, now I have two, and we're going to do a comparison with them, which is the point of today's video. So I'm going to get you guys on the computer, and we're going to plug this into the SDR, and we're going to see which amplifier is better. But first, let's take a quick look inside to see what the differences are. Okay, so let's start with the Acasom. So we have up here a TPH2504, which is described as a single dual quad low power high speed unity gain stable rail to rail input output operational amplifier. That's a really long description. So it is some sort of amplifier, but I'm not exactly sure what it's actually doing, because I'm assuming that this chip here, this ACA0810, is the amplifier for the RF signal. Of course, ACA, Acasom, I assume then it's a proprietary amplifier of sorts. So yeah. We have what I believe is a filter, two filters. They are huge filters. And we have down here a power IC and a lot of power related filtering. As we move along, we have here a switch, because this is a bidirectional amplifier, so it amplifies only RX and not TX. What I have noticed is that the shielded cable is connected to this chassis as the earth, and the board itself is not earthed. I haven't checked it with a multimeter, but I believe that it is not earthed. So let's now move on to the AB868. So here's our input, and we have a variable, we have a pot here, so we can vary the TX amplification. This is also a bidirectional amplifier, but with this we are also able to amplify the TX. So there is not a lot going on this. It's a very big board, and I don't know if it's necessarily needed to be so big. So we have here two very big capacitor cans, and we have here our amplifier, which I can't tell you what it is because the name has been scratched off, but I assume that it is an SPF 5189, which is the most common LNA that is used in such devices that are cheaply manufactured, let's say. One thing I have noticed as well is that this board is using 5 volts, and you can power this with a USB adapter, whereas the Acasom comes with a power adapter, and the power adapter supplies it with 12 volts. I don't know if that makes a difference. So yeah, as we move along, we see here we have a filter, also a rather large filter. We have our switch here as well, and that's all there is to it really. There's not really a lot going on. We do have some power line filtering, but I also noticed that the board on this is earthed, and it earths to the chassis as well. So that's what they are like inside. Not too much going on in this one. The Acasom looks very professionally made, I'll be honest. It looks very, very professional. I like the design, it's very compact, and yeah, let's see how they perform. Okay, so apologies if my voice sounds a bit funny. I'm using my headset for this because it just makes things much easier. So I have my SDR connected. It's a Newelec SDR Smart. And I've connected it to my AB868, so it's not plugged in at the moment. So this is currently the noise floor right now. It's sitting around about minus 123 decibel. So now I'm going to plug in the amplifier. Okay, so as we can see, the noise floor is quite high. Let me turn this down. So the average noise is at 868 is around about 108, maximum 106 or so. We've got a couple of things beaconing around going on, some peaks and troughs going on here, although I don't know what they are. So we have lots of things going on at the moment. I don't know if any of these are beacons from hotspots or what they are. At the moment we're going to just look at the noise floors. So for the AB868, the noise floor is about minus 106. Let's scroll through the frequencies and see if there is any kind of filtering, since it's designed to be for 868. So let's have a quick look around. We have a lot of interference on the 800 megahertz band, or lower 800. Okay, in the 7s as well.
5. Yeah, so we've got a lot of interference also on the 170 megahertz here. We've got interference up to 100 decibel. Also in the 98, which is normal radio, like FM radio. Okay, what's going on over here? This is moving. What about this one? What's going on with this? I don't know what's happening here, but this is moving down. Maybe somebody's doing something here. Oh, there it goes, scrolling down. I think somebody's doing something. Okay, so let's keep going. And we have also some noise from 38 megahertz as well. So there's quite a lot of noise. Yeah, there's a lot of interference throughout the frequency ranges. Goodness. There's noise right up to 90 decibel. So the amplifier is amplifying a lot of noise. So yeah, that's not great, but you know, what can you expect for a 95 euro amplifier? I mean, to be honest, I expected a whole lot more. I mean, it's really easy to make an amplifier, you know, that will do the job, especially at these bandwidths, but you know, it's cheap. So that's the AB868. So let's now plug the Acasom in and see what's going on there. So this is the Acasom, and the noise floor on this is much lower and it's far cleaner. So we're looking at, there's so much going on, I can't get it. Minus 118 to minus 115. So that is a 10 decibel difference when it comes to noise amplification. So let's check the other frequencies to see if this Acasom is filtering those or if it just amplifies everything. Okay, so we've got a lot of interference also on the lower 800 megahertz range. We also have interference here as well, 500 at minus 110. What's this one? Up to minus 100, 488. Okay, but generally it's quite clear apart from 38 megahertz, which has got some bits of things happening there. 58. So the maximum noise floor, so the maximum amount of noise so far is minus 110. Let's just keep checking. Oh. Okay, so here we get up to minus 97. Oh, and here even higher, 94. Okay, and higher. Nothing really. Okay, so the maximum amount of noise is minus 94, which is still quite high. Let's go back to 868. But it filters out the rest of the noise quite well. Let's compare this to connecting the SDR to the antenna directly. So let me disconnect this now and see what kind of things we are getting. Okay, so this is the antenna connected directly to the SDR. So we can see that the noise floor is minus 123. And there's not really much that we can see of other beaconing devices. There's still quite a lot going on, but not as much as there was when we had the Akasum connected to the SDR. And I think the Akasum performed much better than the AB868 in that respect when checking the signal. There was a lot less noise that was introduced as well. So far, the 868 has a noise floor of 106 at 868 megahertz, and the Akasum minus 115, and the antenna itself is down to minus 123. So the AB868 adds quite a lot of noise. In fact, 15 decibels from the antenna. The Akasum is adding 8 decibel. That is quite a lot of noise coming in. Let's check out what's going on with the Nano VNA and see what kind of amplification we're getting these amplifiers. Okay, so I have my Nano VNA connected to my laptop. I have a Nano VNA H4, and I have selected the start of my sweep as 1 megahertz and the stop as 1 gigahertz because I want to see what frequencies these amplifiers are going to amplify. So I'm going to start with the AB868. I'm going to plug that in now and do a sweep. Goodness. So, let's see here. So my marker 1, my red marker is at 167 megahertz, so it's amplifying this frequency. It's amplifying 520 megahertz really a lot. And this peak here, 868 band, it's right here. But it's amplifying the 500 megahertz range really a lot, and also this range here, forget what it was, sorry, 170 megahertz. That's really quite a lot, and the amplification for the spectrum that it's supposed to be at is the worst. So, as we can see, AB868 is doing a lot of not good things. But what happens if we add Sol filter? Let me check. Let me do that 1 second. Okay, so now I have my Sol filter connected. Let's sweep again. Okay, so it's much better, much cleaner amplification, though we still don't have really a great deal of amplification on the 868 band. 868 band. We still have amplification issues on the 510 megahertz range. But the 867 range is much better. It's right, the 867 is right at the peak, which is pretty much exactly where it should be. This is how it should look, except this should be kind of down here and that too. Okay, so I have my AB868 connected. So let's do a sweep. Okay, so there is some filtering, although it's probably not very good. So we have a broad peak here, which comes up to minus 40 dB at 334 meg. But then we have this huge peak here, which sits at 650 megahertz. We have another peak here at 720, and then we have our main peak, which is at 870 megahertz. And we have a gain, only a very small gain though, of around 3.8 decibel. So it's filtering out some noise. It's not great, but it is filtering out some noise. And we do have some gain, some positive gain, which is okay. And then we have also another peak here, a rounded peak at around 970 megahertz or so. So is it good? It's okay. It's not bad. I mean, it could be far better, but let's see what it's like if we add a SAW filter to it. So I'm going to add a SAW filter now. So let me turn off the ABA68 and add this filter here. Okay, so I've added a filter. Let's power it on and do another sweep. Okay, so it's better. It's much better in the lower range. We are still coming up, and we still have quite a strong peak here at 650 megahertz. And we have also another one here, a bit smaller at 720. So these were the other two peaks that were already quite high, but the main interference in this 300 megahertz range has all gone, which is good. We have another peak here though at 520 megahertz. If we could get rid of all of that, that would have been perfect, but we couldn't. It has attenuated the amplification to 1.3 decibel instead of the 3 decibel that it previously was, but we still have this rather strong peak in the 870 megahertz range. But again, it's slowly creeping up. We do have a lot of interference though between 520 and 720 megahertz. So let me remove the AB868 and let's compare this now to the Acasom. Okay, so the Acasom is connected without the filter. So let's do a sweep. Okay, so it's filtering out quite a lot of the noise that the AB868 was already kind of amplifying. But we have a consistent amount of interference from 520 megahertz up to let's say about here. 820. So all of this is kind of leveled out interference. And we have a maximum gain of 3.869 dB, which is slightly more than the AB868, but it's much cleaner. We have a small peak here at 910 and 940. So it's very clean. Again, it could probably be better if we can get this interference down and just get a straight peak up. So let's try to add the filter, the 868 megahertz filter, and see if that makes any difference whatsoever. Okay, it's much better. We've reduced all of that noise, not by a lot, but we've reduced it. It was from 520 megahertz, which is again here. We seem to have a problem in this area. But we have this one strong peak here, a couple of other blips, but average for this interference has moved down almost 10 decibel, and we have a straight peak in the 800 megahertz range for 870 megahertz, and we are making 1.456 decibels of gain, which again is better than the AB868, and the rest of the frequency range is also low in terms of interference. So we've got this one straight peak here. The only other peak that we could try to get rid of is this 520 megahertz range. So it's pretty good. The Axiom performs much better than the AB868, but is it justifiable in the cost? Yes and no. I mean, you could just add a filter to the AB868, then you will be coming into the same kind of cost range where the Akusum is as well. Might I remind you though that hotspots generally have concentrators that have got filters on them, so it might not necessarily be, necessary to add a 868 filter unless you're using an amplifier which, like the AB868, is just amplifying a lot of the incorrect frequencies. Generally, the Akusum without the filter performs quite well, and the AB868 does also perform quite well, but it has a lot more noise. It is possible that you could just modify the AB868 with a filter, and that will not cost you a lot, which will make a big difference. So what is my takeaway? Well, the Akusum in comparison to the AB868 is clearly better. The AB868 will need a filter to perform well, and with a filter you will get comparable results with the Akusum, which doesn't have a filter, and in that case the Akusum will have a higher gain, 870 megahertz range. So I can say that I would recommend the Akusum over the AB868 unless you can get an AB868 far cheaper than what I paid for it, which was 95 euros. I imagine if you can get one for around about 60 euros and you put a saw filter on the end of it, and it doesn't come to more than 80 to 90, probably 100 euros, then I think you're on a winner. Then I would recommend, of course, then the AB868 in this case, because it performs almost just as good, and the price would be cheaper. The only thing is that the box for the AB868 is quite large. It's, I find, unnecessarily large. The Akusum is much smaller. It means you can put it into a smaller area, and it just the Akusum, of course, just looks quite nice with its aluminium case. So yeah, Maybe there's other things that I'm missing out on, but I'm sure you guys will comment that. Let me know if there's something you would like me to try, and yeah, we will see you guys on the next video.